And now we're on our last little video. How do we actually determine protein binding? Well, this is tricky, and one of the things that you'll learn is, when we measure or when we talk about concentrations of drug, we need to be specific about whether we're talking about free concentrations or total concentrations, because the only active form are the free concentrations, right? So it would be much better if we could just measure free concentrations and then just be talking about free concentrations when we evaluate drug concentrations. But the problem is it takes time, as we'll learn here, and it's expensive to determine protein binding, the protein binding of drugs. There's several methods. First of all, equilibrium dialysis. This is the gold standard. I did quite a lot of this in my fellowship when I was in school, actually measuring protein binding of verapamil using an equilibrium dialysis method. We'll talk about that in a minute. You can also use ultrafiltration, gel filtration, and spectroscopic methods. The spectroscopic methods are the quickest but most expensive. There's also in vivo methods. In vivo methods are measuring concentrations of drugs in fluids or in places that only free drug can get to. And one of the most common in vivo methods is to measure drug concentrations in saliva, because the only way a drug can get into the saliva, unless it's administered by melting in your mouth or something, as long as it's not given that way, you can measure saliva, and only free drug is going to be able to go through the membranes to be able to get into the saliva. The problem with that is it's quite variable, because of changes in pH of the saliva will change how much drug will actually move into the saliva. Therefore, you have to maintain a certain pH, and even drinking water or chewing gum or having a mint will change the pH in your saliva. I worked a lot with that, and it's very difficult to reproduce, so that's why it really isn't used. I spent a lot of time doing this to try to measure free concentration of anti-epileptic drugs for kids so that we didn't have to draw their blood, but I was fairly unsuccessful at that, unfortunately. All right, equilibrium dialysis. So what you do is you take your blood and you let it clot and spin it down so that you get just the plasma. So you take out the red blood cells, you take out the clotting factors, and you have the plasma. You put your plasma on this side of a dialysis unit, and then here's your dialysis membrane that's going to be between the protein, because you've got protein in that plasma, right? And on this side you put a buffer. The free drug will move through this membrane to try to equilibrate on both sides. Then you measure the drug in the buffer, the concentration of drug on the buffer side, and you measure the concentration of drug on the plasma side. And then you compare those. So the concentration in buffer over the concentration in plasma will give you your fraction unbound. This, depending on the drug, might take 3 days to make sure the system has come to equilibrium. Usually it's about 12 to 24 hours. So that takes quite a lot of time. Another system is using ultrafiltration. Here we put our plasma, again, as we talked about what plasma is, into this chamber. It looks a little like a prescription bottle. You put it in here, and there's another membrane here, and this is under pressure, and the pressure pushes only the free drug into the ultrafiltrate. And if you measure the concentration in the ultrafiltrate, that will be your unbound concentration. Again, this isn't as reproducible as the equilibrium dialysis. You can also use gel filtration, where you have a column packed with dextran beads with a solution of drug in it, and then you add the protein to the column and then wash it with that drug solution, and the bound protein drug, the bound will elute first, and then you can measure that with your detection system. This I've never used, and here's what it looks like. I'm not going to spend too much time on that because I don't really care. It's just another method. Here's where you use light to look at the change in information between the protein alone and the protein drug complex, which allows you to separate the detection of the bound versus unbound drug. So that's it. All right, we're going to do problems next.